Some minds do not fall asleep by being told to stop. They need something quiet enough to follow. At midnight, the room is dark. Not absolutely. The street outside contributes its ambient illumination through the curtain gap, and the various small indicator lights on the devices in the room produce their constant points of red and green and white, but dark enough that the eye, given time, would adjust toward the state of maximum sensitivity, the dark adapted state, the state the retina reaches after roughly 20 minutes of low illumination, when the photosensitive pigments have had the chance to regenerate and the cells responsible for low light vision are running at their highest gain. The screen is producing light, not a large amount in absolute terms. A phone screen at reduced brightness produces perhaps 30 or 40 lumens, less than a single candle, far less than the overhead light that was on earlier in the evening. In a room during the day, this level of output would not be noticeable against the ambient illumination. The room around the screen is still dark. The ceiling is still dark. The walls beyond the screen's immediate illumination are still dark. But the screen, which the eye is looking at directly, is producing photons at the surface the eye is pointed toward, and those photons are entering the eye, and the eye is not completing its dark adaptation. The light from the screen illuminates the face from below or from one side. The underside of the chin receives most of it, the lower cheeks, the surface of the hands holding the device. This is not the direction from which light usually arrives. Daylight and most artificial light comes from above, from the ceiling, from fixtures overhead. The screen reverses this. The shadow it produces runs upward. The face that the room's darkness surrounds is lit from below by a source smaller than a paperback book, and the light from this source is the only illumination that is currently active in the room. The ceiling, faintly, carries whatever the screen is showing. The colors present at low intensity, the shape of the image visible if the room were bright enough to read them. The dark adaptation that would otherwise occur is not occurring. The screen is producing light at the surface the eye is looking at. The process of rebuilding toward maximum sensitivity in darkness requires darkness. The screen provides the opposite. Continuous photon delivery at the surface closest to the eye. The cells that dark adapt are cells that respond to light by changing their chemical state, bleaching in the presence of light, restoring in its absence. At the rate the screen is producing photons, the restoring is slower than the bleaching. The eye is at a midpoint, more sensitive than in full room illumination, less sensitive than it would be after an hour of complete darkness. This has a visible consequence. The room around the screen is darker than it would appear to an eye that had been in complete darkness for an hour. Not because the room is absolutely dark, because the eye is calibrated to the screen's output and the ambient illumination of the room, the street's contribution through the curtain gap, the faint surfaces of the walls, falls below the threshold that calibration establishes. The screen produces photons across a range of wavelengths. The combination of colors that makes the image appear white or normally colored requires emitters that cover the visible spectrum. To achieve this, the screen uses components that produce short wavelength light. in the range of roughly 420 to 490 nanometers, the portion of the visible spectrum that corresponds to the colors blue and blue-violet. This portion of the output is not incidental. It is required to produce the white and near-white colors that dominate most screens displaying text, backgrounds, and general interface elements. The screen emitting what appears to be a neutral, slightly cool white light is emitting substantially in this range. The photons in this range have a specific property that distinguishes them from photons at other visible wavelengths, not in the quality of the light they produce for vision. At normal illumination levels, the eye does not perceive blue light as different in kind from light at other wavelengths. The image on the screen looks white, or slightly warm, or slightly cool, depending on the screen's color settings. The blue-green component is not visible as blue-green. It is absorbed into the appearance of a normally colored image. But the energy at these wavelengths is present in the photon stream, and it is present at the specific frequencies that match the sensitivity of a set of cells in the retina that are not involved in seeing the image. These cells evolved in a world where blue-green light at this intensity meant sky. The sky at midday, dominated by the scattering that selects shorter wavelengths and sends them toward the eye from every direction. The sky at dawn, where the light source is still low and the atmosphere scatters the blue wavelengths across a wide field. The sky at dusk, when the same scattering produces the last blue dominant light before the transition to darkness. The cells that evolved to read this light evolved in the period before any source other than the sky, and the sun produced blue-green photons in quantities sufficient to activate them. In the long period before screens, the only blue-green light available at midnight was starlight, too faint at ordinary star densities to meaningfully activate the reporting cells. Moonlight at full moon is bright enough to influence the clock's chemistry, but not the same wavelength composition as sky. Firelight is warm, red-shifted, not the range the reporting cells prioritize. The candle, the oil lamp, the fire, none of these produce the blue-green output that the cells are built to read. The reporting cells, across almost the entire history of the eye, received their significant signals from the sky. They are calibrated to read sky. At midnight, they are reading the screen. The retina contains cells built to see. It also contains cells built to report. The first group makes the image, the edge of the screen, the shape of the hand, the pale surface of the ceiling receiving the screen's scattered light. Their output reaches the part of the brain that assembles the visible world. The second group does not make the image. It does not care what the screen is showing. It does not register the text or the image or the interface element at the center of the frame. It responds to one thing: the sustained presence of blue-green light, the wavelength range that, in the world outside screens, corresponds to sky, to open sky at midday, to the quality of light that marks the transition from night to day. The report goes inward, not to the visual cortex, not to the region that assembles the seen world, to the small clock in the brain that keeps the body aligned with day and night. The clock does not see the screen. It does not read the text on it. It does not know the hour displayed in the corner of the interface. It receives the report. Light is present. the clock adjusts. What it adjusts is not a number. It adjusts the phase, the position in the daily cycle. The body should be in the dark hour state. The clock has received a report that says light is present. It moves the phase toward day. It sends a signal to the structure that produces the chemistry of darkness. The chemistry of darkness is reduced. The clock runs this adjustment without consulting any other part of the brain. The decision, if it can be called a decision, is made entirely at the level of the cells that receive the report and the structure that processes it. The part of the brain that knows it is midnight, that knows the overhead light is off, that knows the screen is a screen and not the sky. That part receives no input here. The clock does not receive the context. It receives the photons through the cells that report them. The cells are calibrated for one question: blue-green light present or absent? At midnight, with the screen on, the answer is present. At midnight, in the absence of a screen, the reporting cells would be quiet. The ambient illumination from the street, passing through curtains at low levels, is not in the right wavelength range or sufficient intensity to activate them significantly. The indicator lights in the room are red or green, not blue-green. The room at midnight, without the screen, is dark enough that the report going to the clock is night. The clock, receiving this report, maintains the chemistry appropriate to night. In the blood, melatonin is rising. The compound the clock uses to signal darkness to the rest of the body's biology. It does not produce sleep directly. It carries a signal, dark hours. Processes that require this signal, that are waiting for it, that run at their full rate only when it is present, begin running when it arrives and continue as the concentration climbs. By midnight, without a screen, the concentration is near its peak for the 24-hour cycle. It has been rising for several hours. It will remain elevated through the early hours of the morning. The body at midnight without a screen is in the chemistry the darkness produced. The processes that require this chemistry are running. The body has received the full signal that darkness carries from the reporting cells through the clock, through the structure that releases the compound into the blood. The chain is complete. The full night chemistry is present. The screen changes this. The reporting cells in the retina receive the blue-green photons the screen produces. They activate. The report changes. Light is present. The clock receives the updated report. The chemistry of darkness is reduced. The melatonin that was rising has been interrupted, not stopped, but lowered from the level it would have reached by this hour without the screen's contribution. The suppression begins within minutes of sustained exposure and continues for as long as the exposure continues. The clock does not ask whether the light is appropriate to midnight. It receives the report and adjusts accordingly. A brief flash of blue-green light would produce a small response. Sustained exposure produces a cumulative one. The screen has been on for the duration of the session, tens of minutes or hours. Each minute of sustained exposure has contributed to the total activation of the reporting cells. The integration is not a discrete event. It is continuous, accumulating at the rate the cells are activated, building across the duration of the session into the total signal the clock has been receiving. The screen did not need to fill the room with light. It only needed to reach the cells that report to the clock. Breath enters, breath leaves. Between breaths, the air holds its density. The chemistry that was running for the dark hours is running at reduced levels. Not absent, the suppression at this exposure level is partial, not complete. But the body at midnight, in this room, with this screen, is not fully in the dark hours. The clock has received the report of light. The signals that follow from that report are running. The biology that receives those signals is responding to what the signals say. The body is doing what a body does when the clock says light is present. Not fully, not with the full chemistry of day, not with the full alertness and metabolic engagement that daylight and waking produce, but not in the uninterrupted dark hour chemistry either. In the intermediate state, the intermediate state has a texture. The specific processes that require sustained darkness to run at their full rate are running at a reduced rate. The chemistry that would be present in the blood at this hour without a screen is not present at its full concentration. The body is not aware of this as a sensation. There is no signal that corresponds to insufficient dark hour chemistry. The body simply does what the current chemistry allows, at the rate the current chemistry permits, which is a different rate from what the uninterrupted night would produce. The cells that report to the clock do not distinguish between the sun and the screen. They respond to the wavelength and the sustained level of illumination. The screen produces blue-green photons. The cells respond to blue-green photons. The report they send is the same report they would send to dawn. The evolutionary history that shaped them did not include screens. It included the sky at the transitions between darkness and day. The dawn sky, when blue-green wavelengths begin to dominate and the clock first receives the report that a new day has begun. The dusk sky, when those same wavelengths are last present before the report shifts back to darkness. The cells are calibrated to read this transition. They cannot read the calendar. They cannot read the hour on the device. A source that produces blue-green photons at midnight produces the same report that dawn produces, because the cells that make the report can only read the photons. The screen does not know this. It is producing the wavelengths required to render white and near white at a sufficient quality for the display's purpose. The blue-green component is not a feature aimed at the reporting cells. It is a consequence of the physics of producing the colors the image requires. The reporting cells are not the intended recipients of this output. They receive it because it is present, because they are in the path of the light, and because the wavelength falls within the range they were built to read. The screen is not trying to update the clock. The clock is being updated because the photons are there. The response is the same response. The clock update is the same clock update. True wisdom cannot be captured in words. It is found only in the silence between them. In the brain, the clock is running at the phase the screen has contributed to. The chemistry in the blood is at the level the partial suppression has produced, lower than it would be without the screen's blue-green contribution, higher than daylight would produce, somewhere in the reduced range that an hour of screen exposure at midnight establishes. The photons that produce this are no longer traveling. They left the screen, crossed the short distance of the room, entered the eye, reached the layer of reporting cells at the back of the retina, activated them, and were absorbed. The cells sent their signal. The clock received it. The chemistry shifted. All of this happened before the next gesture changed the pattern on the screen. The response was running before the conscious brain registered what was on the screen. The screen is still producing blue-green photons. The reporting cells are still receiving them, still activated, still sending the same signal that says light is present, still integrating the cumulative exposure of the session into the report that runs continuously to the clock. The clock is still receiving the report. The chemistry is still running at the level the report requires. The room is dark. The body is in the position of sleep. The chemistry is not in the state that full darkness would produce. The gap between those two facts is the width of the photons that are traveling right now from the screen to the eye. The photons that are arriving at the reporting cells at this moment, that are producing the activation, that is producing the signal, that is maintaining the clock's current phase. The photons from the screen continue to travel the short distance from the surface to the eye. The clock continues to receive what they report. Breath enters, breath leaves. Between breaths, the air holds its density. When night falls, the archive remains,